Well, thanks so much for CSEC for putting this on. I'm really excited to be here today, especially since I've got like a mini hacker with me in the audience. We're here to talk about malware and the GIST. I don't know if you guys get that little joke reference there, but I think I'm pretty snazzy for coming up with that. My name is Paul McCarty. I am probably most well known in Australia for being the founder of SecureStack. I've also started several other companies. I've worked for some large organizations in my career, and I've worked for some small organizations in my career. And by the way, I just want to verify, I should have probably asked this. I'm talking for 45 minutes. Is that correct?
Yes.
Yes. All right, cool, sweet, thank you. Just want to make sure. And right now, I have a full-time gig as head of research for a company called Safety, which is a software composition analysis and application security company based out of beautiful Vancouver, BC. I'm really enjoying doing that. I write a lot of open source. I'm like crazy obsessed, and tools like Lovable and some of the other AI code generation tools make it really easy nowadays. I'm particularly like one of my most well-known open source projects is called DevSecOps Playbook, which basically I wrote 3 or 4 years ago. Talks about how you build a DevSecOps program for any size company, big companies, little companies, what have you. Visualizing the software supply chain pretty much talks you through exactly that. Malice is really cool. It's a tool I've written recently. I'm actually really excited. I haven't really launched it. I briefly mentioned it at DEF CON when I was there a couple weeks ago. But more recently, I've written a couple of tools, Gimme Pats, Super Confused, which are where I am going to talk about in this talk today. So yeah, like I said, I write a lot of open source. I'm actually part of the OpenSSF. I work on the malicious packages program there. We're going to talk about today about open source malware. And in a second, I'm going to talk a little bit about what is open source malware. But really the things that we're going to talk about today at a very, very high level are how this malware, how open source malware is delivered, that unlike other malware, it specifically targets devs, developers, software engineers, and CI/CD pipelines. Traditional binary-based malware does not typically target CI/CD pipelines. The kind of stuff we're going to talk about today absolutely does. Unfortunately, there aren't a lot of good security tools that actually help us with open source malware, which we're going to talk about today. I'm going to call out some companies that could be doing a better job about this. And unfortunately, we're not really doing a good job of tracking the threat actors that are behind a lot of these attacks. And frankly, InfoSec teams don't understand open source malware. So first, before we talk about open source malware, let's talk really briefly about what is the software supply chain. Have we all heard about this crazy thing? What is the software supply chain? Have we all heard about this? What is the software supply chain? Does anybody want to like define it for me? Nobody? Okay, well, I'll define it. Software supply chain are basically any of the components that you use to build an application, a software application. Now, the thing is that the software supply chains have gotten a lot more complex in the last few years, and that's for 3 main reasons. First, we're using new languages to write and develop in these applications in. For example, we're using JavaScript. Where does JavaScript run? Anybody? Your browser. It runs in your browser. Where does PHP or Go run? It doesn't run in your browser. It runs on a server somewhere typically, right? So basically, in that, I know that's an oversimplification, but the point here is that open source malware, which is often, as we'll see here today, is often JavaScript, runs in a browser. And that means the attack surface of how that open source malware works is different. It's targeting that browser. Next, these applications that we're building are running on new infrastructure, things like Kubernetes, containers, Lambdas, and all of these things come with their own kind of mechanisms to keep them running, right? The orchestration fabrics and what have you. And that brings along new attack surfaces as well. And finally, these applications are running in the cloud. They're cloud native or cloud centric. Now, when you build something in AWS, I think we oversimplify. We think we're deploying something to AWS or we're deploying something to Azure. But really, most of the time, we're actually using services from these cloud providers that basically replace source code and other services that we would typically build into it. So a good example of that is if we use Azure Entra ID, or if we use AWS Cognito as our identity provider, that's not something that we're building and storing and maintaining ourselves. We're actually asking the cloud for that, right? Or AppSync, really good example in AWS. So it's more than just hosting something in a cloud provider. It's about using those services from those cloud providers as part of the application itself. So what you're seeing here is you're seeing something that I wrote several years ago, which is the visualizing the software supply chain. It's 10 stages. I'm going to go over those 10 stages really, really quickly. That's not what we're here to talk about today, but I just want us to understand this. First, at the far left are the people that write and test our software applications, right? These are developers, QA, maybe some DevOps people. Next, it's any of the stuff that they use on their local workstations, IDEs, AI, now AI agents like Cursor and what have you. Any local tests, these are the local requirements that are running on those workstations. Next is the actual source code itself. This is source code either that you're getting from open source, which typically accounts for somewhere between 75 and 90% of your application, and source code you're writing yourself. This is libraries, frameworks, what have you. Next is the integration phase. So if you've got a bunch of developers working together, those developers, as they check in code, that code has to come together and make one unified code base, right? That's called the integration phase. That's when you take a bunch of different disparate pieces of code and bring it together to make one unified thing. Then you got to do something with that integrated code. You got to deploy it somewhere, and that's where the next stage, deployment, comes in. Next is runtime. Once you deploy it somewhere, now it's running. Customers, people can use it, right? They can actually interact with it. Now, behind the scenes, there's probably hardware that's involved. A good example is GPUs for AI or for crypto. Even though that's hardware, it still is required to be part of the application. You can still think about it as being part of the software supply chain. Next is the DNS. These are the names that we ask, www.csec.com, right, or whatever, right? Gov.au, those kind of things. If that DNS entry doesn't exist, can you get to your application? Can you use it? Probably not, right? And finally, the last two stages, services. This is all the kind of a combination of all the different third-party things you're using, API gateways, third-party APIs, different SaaS solutions. And finally, the cloud. Now, here's the thing. What we're going to talk about today, open source malware, is typically most commonly thought of as being a software package or a library that a bad guy attacks. Now, here's the thing. I have seen package-based malicious open source malware attacks affect almost all of those stages, right? So it's not just the source code stage that can be attacked with a malicious package. Does that make sense so far? Okay, nobody says no, so I'm gonna go on. There's two types of software risk. The first is the accidentally vulnerable. This is what most of the industry has built security tools around. Your SCA, your software composition analysis tools, your static analysis tools, even DAST and some of these other things, they're built to basically find vulnerabilities that are in your application, are in your source code, that developers put there accidentally. They didn't do it on purpose. They didn't create SQL injection or cross-site scripting opportunities. They didn't do that on purpose, right? They did that accidentally. And so we've got a bunch of different things out there that help us with those kind of those vulnerabilities. You can think about this like the OWASP top 10. Every single thing on the OWASP top 10 is about accidental software risk. And these things, when you scan source code, it'll stand out, right? You'll see SQL injection. You'll see the fact they're not using an ORM or whatever the case is in the source code. These things are accidentally put there by developers. And when you run security tools against the source code, what you get is findings. You don't get like simplistic Boolean output. You get findings. The findings say, hey, you've created this SQL injection opportunity. You need to use this other library or write your function in a different way. It's kind of a complex thing, right? Now, let's counter that against what we're going to talk about today, which is not accidental vulnerabilities, but intentionally malicious attacks. These are written by bad guys, bad people, criminals, typically. Nation states as well. They try really hard to hide. Unlike accidental vulnerabilities, nobody did it on purpose, so they're not trying to hide it, right? Whereas the bad guys try to hide their attacks. They typically like using native JavaScript payloads, and we'll talk about why that is. But like regular malware, they'll still have C2. Does everybody know what C2 is? Command and control. This is basically the server that the attack is talking back to. And they will still exfiltrate data from the compromised host, just like normal kind of malware does. And they do that by using install scripts, which are part of the JavaScript package ecosystem. But when you study these, unlike the findings you find over here, like, oh, you shouldn't use that library, or that function is insecure. Over here, if you study these, what you get out of them is things that InfoSec teams can understand and do something about. IP addresses for exfiltration, IP addresses for C2, domains for exfiltration, emails, file hashes, GitHub and NPM counts. These are all things you can track inside of your InfoSec tools and you can do something about. Whereas on the accidental vulnerability side, unfortunately, InfoSec teams just don't really know how to kind of consume those findings. Does that make sense? Am I doing a good job of explaining the difference between the two? Somebody say yeah. Yes. All right, there we go. I like it. All right, what is open source malware? I wrote this morning about 6:30 in the morning. I was not caffeinated, so I don't know if my spelling's gonna be right, but open source malware is really any malicious component that's used as part of your application. Most commonly, we think about this as like a software package thing, like libraries that you download from places like NPM, PyPy, Maven, Docker Hub even. But it's more than that. It also can be software repos, libraries that we pull in from places other than registries. And it can even be things like content delivery networks. There's a bunch of content delivery networks just for JavaScript. And guess what? Some of them are straight up malicious. And there's other kind of open source kind of components. But anything that comes from an open source community and is malicious is, by definition, open source malware. So now we're going to talk about my NPM, my NPM obsession. I'm famous for picking on NPM. Why is it so important for open source malware? Well, first, by definition, the package ecosystem in NPM, Node Package Manager, has install scripts. It's like RCE by design. It's like built to do that. So it's got something called pre and post install scripts. So you can build a package, a JavaScript package, and then in the scripts you can say, now use this to steal data and send it to my C2. It's like perfect. The bad guys don't have to do anything. It's there. They built it for them. The barrier to entry is really low. You can sign up, you can create an NPM account, and you can be deploying malware in 2 minutes. Anybody can claim a namespace. So on NPM, there's npmjs.com, and then there'll be an @ symbol. And unfortunately, let's just say that @Microsoft was available, which is not. But if that was available, you would not have to prove that you've got an email address or you own the domain. Instead, you can just go and grab that @ symbol, right? Which means that bad guys can grab really, really compelling namespaces on NPM that look legitimate, but in fact, they just were the first ones to grab it. Package metadata in NPM can be faked. And so when you look at a package on NPM, you're like, oh my gosh, it's got 10 million downloads. This must be great. Well, guess what? Those 10 million downloads can be faked. And so a bad guy can create a malicious package, add a bunch of fake data to it, makes you think that it's legit. You download it and you're pwned. Account takeover, ATO. Account takeover is pretty easy with NPM. Has anybody been paying attention for the last 3 or 4 weeks? We had several major NPM attacks that all involved account takeover. One maintainer alone, a guy named Jordan, his NPM account name is Quix, Qix. That person alone manages, that person alone got phished. The phishing email came from an NPM lookalike domain, doesn't matter. But the packages that were compromised in that one attack, 18 packages, are downloaded 2 billion times a week. And that was just one attack, one person. The applications that you're using right now on your phones and on your computers would have downloaded some of those malicious packages, right? And who has visibility into that? And that's why I want to be here today talking to you about open source malware, because it doesn't get a lot of visibility, not a lot of people talking about it, but it's a very, very beneficial thing for criminals to be attacking. And unfortunately, when I turn stuff into NPM, I find a malicious package, which I do all the time. It takes them a long time. to remove it from NPM. I found something in December, a terrible package called express.exp. I let NPM know about it, and guess when they took it down off the NPM registry? May. 5 months where a known malicious package was compromising people all around the world, and NPM, it took them 5 months to remove it. Finally, GitHub Security Advisory, which is one of the main malicious databases out there, doesn't track malware data. So they don't track authors, they don't track any of the kind of stuff that you'd want to, and so they don't have any good data about the bad guys that are doing this. This is a study from Sonatype, and basically what this found is that 98.5% of all malware is hosted inside of NPM. PyPy, this is the Python registry, less than 1%. NuGet, less than 0.5%. The vast majority of it is in NPM, and there's a bunch of reasons why. Now, most of the malware is in NPM, but also you layer on top of that the fact that JavaScript as a language uses way more secondary, or what are called transitive dependencies, than any other language. So this is data from GitHub. PHP has an average of 9 top-level dependencies per project on on GitHub, but it has 70 transitive or third-party. So basically what this means is that these 9 packages that it calls in directly, they in themselves have dependencies, right? And those packages have dependencies. And those packages have dependencies. Those are called transitive or third-party dependencies. And there's 70 of those for the average PHP project on GitHub. Look at JavaScript, 10 direct, but 683 indirect dependencies or transitive dependencies. This is the problem with JavaScript. It just pulls in way more packages that you have no idea about. And that makes it really easy when we already know that NPM is where most of the bad stuff is, and you're calling in like exponentially more packages. You layer those things on top of each other and you get a very, very dangerous ecosystem. Now what we're looking at here is actually some data coming from a company called SafeDep. Basically, they took a look at all the malicious packages that they looked at last year, and they basically identified that 78% of those malicious packages abuse those hooks that I was talking about, those post and pre-install hooks. 65% of the malicious packages they looked at exfiltrate system information, so on and so forth. The data here is not really super, this is not what I'm asking you to remember here. What I'm asking you, what I'm showing you here is the fact that there's a lot of different ways that bad guys can use malicious packages. It's not just like, typical dependency confusion attacks and what have you. So how do open source malware evade security tools? All right, this is going to be a bit technical. So if you have any questions, say, Paul, hold up your hand, say, I don't understand that. You used an acronym, I don't understand, because I don't want to be talking, I don't want you guys not to understand what I'm saying here. But I am going to go into some detail here. So one of the differences between open source malware and kind of typical malware is that open source malware does not use binaries, or usually doesn't. I mean, the vast majority of the time, it doesn't. Hey, by the way, MC, can you give me like a 10-minute warning when we're good to go? Sweet, thanks. So it doesn't use binaries, right? And instead it uses native JavaScript or whatever the language is. Unfortunately, the common techniques that people have for malware analysis, reverse engineering, disassembly, hashing, things like that, most of that is useless because it's not a binary. It doesn't matter what the hash is. You can just add an extra character at the end of it. It changes the hash like that. So people that like reverse engineer malware binaries, typically when they come to like the JavaScript world, can't reuse a lot of the same skills. The files that the bad guys are using are highly iterative. So they'll deploy one version of a package that's malicious, then they will immediately deploy another version. Then they will immediately deploy another version. And each one of those versions can have new C2, can have new payloads, can be totally different from the last one. And that complexity and that highly iterative nature of it is very, very different than traditional malware. Sandboxes like AnyRun and Joe's, some of these kind of online malware sandboxes just don't help with JavaScript. They just don't. They don't give you any benefit. In fact, most of the time they won't even run the JavaScript payloads. Who's heard of obfuscation? All right, there we go. I'm seeing some hands now. Obfuscation is when you make something more complex on purpose, right? That's really what it means. JavaScript itself is an interpreted language, which means that when you run a piece of JavaScript, you can just go and look in your browser and see exactly what it's doing. You just go to developer tools, you look in payload, you'll see what the response was, look at the request, and you can see what it's asking. It's all there for you. So what bad guys have done to try to get around that is that they've taken the source code for their malicious packages and they've obfuscated it. And there's a bunch of really, really good tools out there that take like human readable JavaScript and make it gobbledygook. You cannot understand it, right? And what they'll do is they'll layer different layers of obfuscation on top of each other to make it impossible to de-obfuscate that. And that's a big problem for me. And it forces a human to get involved. It forces somebody like me to get involved. Luckily, this is one of the places where AI can actually help a lot. LLMs are actually pretty good at taking obfuscated JavaScript and de-obfuscating it. Now you have to be careful because sometimes, as we know, LLMs are non-deterministic. You ask them the same thing 5 times, they're going to give you 5 different answers. So you have to be careful about accepting what they give you at face value. But in my experience, they're actually pretty good at de-obfuscating and understanding JavaScript. Next, as I mentioned earlier, this JavaScript-based stuff runs in your browser, which means it can target people in a very different way. So some of these attacks that have happened over the last 2 or 3 weeks are actually attacking developers on their own machines when they run a development web server on their machine. They're not attacking a server. They're not attacking something in the cloud. They're attacking a developer that has run a development version of something on their laptop. And that's a very unique kind of attack methodology. These payloads can be very flexible. I have seen the same malware that has 2 different components where it's attacking the developer when they run it locally on their machine, but it's also attacking in the CI/CD pipeline. The flexibility of these payloads is really unique. And because they're so iterative, they can deploy these things and update them and make them better really quickly. I looked at one piece of malware last month. It had only been out for 30 days, a month, and it had 19 versions. So almost every day, the bad guy kept making it better, kept making it harder to find and more productive for them. When these things run in the browser, they can access anything the browser has access to. So like session tokens, cookies, stored passwords. All of these things right now are being attacked by open source malware, JavaScript-based open source malware, as we speak. And God help me if you're running like a crypto component, like a browser extension. There is so much malware in NPM right now. If you're running some sort of Chrome extension that has something to do with you and your wallet and your crypto assets, be very careful because bad guys are actively attacking this as we speak. That was my PSA number 1 for the day. A lot of this malware is targeting developers, like I just said. So basically, they're targeted for two reasons. One is to deploy the malware, but the other is to then take over what the developer has access to, right? So they're deploying the malware on the developer's workstation, but then they are also using access tokens and other kind of things that they can steal to then take over things that developer has access to, like AWS, GitHub, NPM, what have you. It's a very brutal, multifaceted attack chain. Security tools that developers do use, things like static analysis and SCA, guess what? They have 0 help. 0. They don't help you with open source JavaScript-based malware at all. Not at all. Unfortunately, a lot of the SCA providers say they do, but anyhow. Many developers don't run EDR. Do we know what EDR is? Like things like CrowdStrike, SentinelOne, endpoint detection and response. It's basically like antivirus, the modern next-gen antivirus. CrowdStrike, SentinelOne are amazing platforms. I have SentinelOne running on this laptop right now. But the thing is that developers a lot of time say, oh, if I run EDR, it interferes with me being able to do my job. And so basically they don't have to run it, right? Or they say, hey, can you at least exclude this directory structure? And because of that, bad guys can take advantage of the fact that developers are not running the same protections that other people inside the organization are. And developers are often running a lot of browser extensions, right? So these are things to help them, like look at JavaScript or, built with other kind of tools. A lot of those browser extensions right now are being targeted by open source malware authors, those browser extensions. And this is one of the reasons that Chrome and Google is really kind of putting a lot of energy into how do we make the browser and the extensions that run in the browser more secure. And then AI tooling. The number of JavaScript and Python-based malicious packages that I see targeting MCP, anything that's new and hot, and people are quickly, things like MCP. We've all heard of MCP, right? So model context. Basically, it's AI. It's how you interact between APIs and tools for your AI agents. A lot of people don't really understand what MCP is, so they're going out and they're finding stuff, they're downloading it, and bad guys are taking advantage of that. They're just creating a bunch of fake MCP things. You download it and you get pwned. It's that simple. Bad guys are also using open source malware to target CI/CD pipelines because there's no EDR, there's no antivirus running in CI/CD pipelines. There's basically no intrusion detection. There's really not any security tools typically running there except for static analysis and SCA if those are even running. And as we said, those actually don't help you with this kind of stuff. CI/CD pipelines actually call libraries and containers themselves. That's what CI/CD pipelines do, is they run Docker containers and install stuff to test and deploy your code, right? So all those containers that they're using, guess what? Those are being targeted right now by bad guys. A lot of the logging isn't there for CI/CD pipelines. In fact, GitHub, if you have a free GitHub account and you're building in GitHub Actions, after 90 days, your logs, they're gone. So if you need to do incident response, good luck with that because there's not going to be any logs there. Continuous integration is a really important thing. I don't know how many people do we have in here that have got some sort of background in software engineering? Okay, we got a smattering. Continuous integration is where really two important things come together. First is the company's core intellectual property in the form of their source code. That comes in contact with all kinds of API keys and access tokens, AWS tokens, and things like that. It's a very, very powerful place when those two things are there, and that's why bad guys are targeting that area. How are we doing for time? Cool. Open source malware. What I've noticed, because by the way, I study this every single day. I do this for my job, but I also do this in my spare time. I've built a whole open source malware kind of SaaS database thing that I'm working on with my kids. My kids are actually, my son is asking me to pay him because right now he's my top contributor to this open source malware. He's like, Dad, when are you going to start paying me? I'm like, mate, you're 8. I'm going to start charging you from room and board. The point, and the reason I bring that up is that unfortunately the most popular malicious package databases out there, GHSA and OSV, aren't particularly good, right? First, they weren't built to hold malicious package data. They really weren't. They were built to hold vulnerability data, that first type of software risk, right? Not the second type. And many security vendors use OSV or GHSA as their core way to find out about things and about malicious packages. And because GHSA and OSV are so bad at doing that. And by the way, I'm the lead for malicious packages at OSV, so I'm talking about something I know very deeply. It was not built to do the thing that it's being asked to do. It's really easy for bad guys. What they'll do is if somebody targets them, if somebody reports them to OSV, they just remove their own package from NPM, and then OSV and GHSA just forget about it. And then they just wait a few months, and they use the same package name, and they just redeploy new malicious packages. 10? Cool, thanks. 10 minutes, just 10 minutes. Bad guys are aware of this, and they know how to leverage this. And just the number of malicious packages now that I see that are not actually being deleted by GitHub or NPM, but instead are being deleted by the bad guy, because the bad guy knows if I delete it, I can wait a while and I can come back with the same name package and I can do this all over again. One of the differences between open source malware and traditional malware is that open source malware doesn't go boom, right? It doesn't detonate. You execute traditional ransomware or malware and it does a bad thing. That's not how open source malware works. First, it's interpreted, right? And next, a lot of times, like the malware requires both the source code and something that NPM itself does. So the actual bad thing is a combination of the source code and the registry together. And like the smart bad guys, the really mature bad guys, right? Like the nation states, they don't use those install scripts that I talked about before. Instead, what they do is they use on import. So basically, what they do is they create a library that actually does what it says, right? So one of the most famous versions of this is a package that I found in January this year, which pretended to be a Web3, like a crypto event logging library. And guess what? It did that really well. It actually logged all your events in the Web3 application. But it also stole the data of every single crypto transaction and sent that to a really well-hidden C2. So the good stuff happens on import. That's what that's called, on import, rather than using those install scripts. Now, bad guys, they like to take advantage of what's hot. And right now, I did some quick math and I figured out these are the three main things that bad guys are using. So Vite is a new front-end JavaScript that's based on React. It's a new JavaScript front-end framework. MCP, as I mentioned, which is Model Context Protocol, which is this AI like connecting AI agents to other stuff and tools and what have you, making it interoperable. And finally, Solana, which is a cryptocurrency and blockchain technology. The number of attacks that I'm seeing, those three alone probably account for maybe, I'm just going to pull this number out of the air, probably 50% of the malicious packages that I research day to day. Here's one guy, one bad guy. This is an actual bad guy. Vincent Quark, of course, that's a made-up name, deployed 62 MCP related. This is all in PyPy. 62, and it just basically took security agent MCP server and MCP client tools and Markdownify and Google and basically just trying to throw stuff at the wall and hope that people download it. And guess what? They did. They downloaded some of this stuff and got pwned. Really quickly, this is basically when I find, this is me. Sorry, this is the bad guy writing a malicious package. This is typically, I usually find it within a day or two, but let's just say it takes me 3 days to identify that something's malicious. I then turn it in to OSV, and then typically they publish it to the OSV database within 6 or 7 days. Now here's the problem. Then it takes all this time for NPM to actually remove it. So the bad guy has this whole window here to make hay, right? Because the system is so poorly built to be able to identify these things and turn them in. I'm gonna skip ahead just because of time. Basically what I'm doing here is I'm calling out a couple of SCA tools. I won't mention them, but the names are probably on the screen right now. I'm calling them out to show how bad they are at actually identifying malicious packages. Same thing with static analysis. Static analysis just wasn't built to identify malicious packages. That's what these screenshots show. Excuse me. My apologies. How does OSS malware, open source malware, bypass EDR? Well, it targets people where EDR probably isn't running. The payloads are very simplistic. They're singular-based payloads. They don't run a bunch of times. Ransomware gets found by EDR because it tries to zip up multiple files. And that pattern is what the EDR tool is looking for. Open source malware typically doesn't do that. All those other things that I talked about is why. Now, real quick, I want to talk about the Lazarus Group. Has anybody heard of Lazarus Group? Yeah, we got some hands. What country is the Lazarus Group from? Korea. North Korea. Be careful, North Korea. Lazarus Group is a nation-state actor that is all up in the malicious packages space. They are basically targeting crypto. They only care about, they want to steal your crypto. They don't care if you're one guy or 1,000 people, right? They are targeting your crypto, and they're doing that in a whole bunch of different ways here. One of the things they do that's really unique is that they target cross-site scripting, and they basically want developers to run their payloads on their laptops, and that's how they're going to steal your code. Here's an interesting one that I found. This was an Indonesian gang. I just called them Lira. They basically were mostly pretending to be Vietnamese women. I don't know why, but that was their thing. They're all based in Indonesia. Does everybody know what OPSEC is? Operational security? Their OPSEC was terrible, so I actually found them. Most of this gang are actually high school students in Indonesia. I found their Instagram. I found their social media posts. It's not hard to find them. Their technical savvy is low, and that's why they like to exfil to Discord, because they don't actually have to build their own Discord, their own exfil. Then there's the Russians. Excuse me, my apologies. The Russians have really spent most of their time working on binary-based malware, but have moved really to JavaScript payloads now. And bug bounty researchers. On a month-to-month basis, between 30 and 50% of the malicious packages I see are actually bug bounty researchers trying to get bounties on programs. And this is a problem because it creates a lot of noise. I have to figure out what's just a researcher and what's an actual criminal. So I'm actually working with some of the bug bounty platforms like BugCrowd and HackerOne for them to make the researchers that are using their platforms kind of follow a code of conduct to do this. So it makes it easier for me to identify them. And here's when I put this slide up at DEF CON, like 100 hands went up with their cameras taking pictures of this. Because if you were going to make, there's one camera, there's one phone. If you were to make the perfect open source malware, this is my playbook to do that, right? I'm not going to go through all of it because of time. But the reality is that this is not rocket science. If you follow a few kind of things, you're going to have a very successful payload. Oops, I'm going the wrong way, sorry. All right, and here I'm wrapping up now. Basically, how do we protect ourselves? You can scan your package manifest and your SBOMs. I've written a tool called Super Confused that's going to help you do that from a dependency confusion perspective. You can go and find it on my GitHub, github.com/6mile, 6MILE. That's my handle. That tool, like you can point it at like online GitHub repos, and it's going to find dependency confusion opportunities. Next is install a source code firewall. Basically, this stops you from installing malicious packages. There's a number of these out there. Datadog has a good open source version called the supply chain firewall. I'm working on one at Safety, which is called the safety firewall. Sonatype has had one for years called the repository firewall. If you're interested in actually being proactive on your developers' laptops and blocking this stuff, you can check out one of those 3 projects. And finally, I've written a really cool tool called Malice. Malicious open source software, you say it Malice. Basically, you point this at your source code, and it will identify if you've got any malicious packages running in those repositories or packages. And finally, here's a bunch of places where I go to learn more about open source malware. So if you want to take a shot of that screen, there you go. You've got some good Twitter accounts and some good repositories there, including the Datadog malicious packages repository. And that's it. I'm Paul McCarty. Thank you so much. Appreciate it. Do we got time for a question, or we run out of time?
Yeah, we can do questions.
Hey, does anybody have any questions? We got time for a couple. Any questions? Oh yeah, sorry.
Yeah, you mentioned earlier.
G'day, Luke.
The threat actor published multiple versions of packages, right? Each time it got a lot more complex and harder to find.
Yep.
Do you find that looking at the earliest package is an easier way to detect malicious packages in that case?
That's a really good question. Yes and no. There's a life cycle there. Like first, when you look at it, like on NPM, like you and I do, when you look and you see how many versions there are, a lot of the bad guys now are actually deploying 1 or 2 legit-looking packages at the end. And this is a really sneaky technique. Basically, if they deployed like 3 or 4 malicious versions, or just even one version that's malicious, then they'll deploy a version that's not right after that, so that when somebody goes and looks at the latest one, they're like, oh, that's fine. And what happens is they're counting on people calling that specific version of that. So I always go back and look at the first version of it just because I want to look at, like, it's the rings in the tree. You can like decompose the attack looking at those. The Nix attack that used the AI prompts, for example, I really looked at every version of those packages to identify how the AI prompts evolved over time. And that gave me so much insight into what the bad guy was actually trying to get at by looking at all those different versions. So yeah, good question. Any other questions? Yeah. Hey, mate.
I guess I'm just understanding a little bit of how it works. So it's you're downloading libraries to then for developers to use in their code, and then
Yep.
while they're calling that, then it's calling the functions, and they're getting hacked through that.
Yes.
Okay.
Well, that's the better ones, which are called on import. So basically, if you actually import the library and then use some function or functionality that's inside of that library, that's the sneakier, better way to do it.
Yeah.
The dumber ones are where they just call those pre and post install scripts, and it just what's the content of the package doesn't really matter. It's like literally in the package.json. It's like bash reverse shell. It's that simple. So it just stands out, which is why the good ones don't actually do that. So, but that having been said, some of the good ones use those pre and post install scripts in some kind of unique ways, or use it in combination with the import. So it's just there's different kind of ways that they can attack from there. But they're good. The really hard ones to find are the on imports. I think we probably should. Do we have any other questions? All right. Well, cool. Thank you so much, guys. I appreciate it. Cheers.